Hi everyone, today we are going to discuss the matte polychrome surfaces and the consolidant used as fixatives when these polychrome surfaces are weakened by their degradation with powdering surfaces or detaching flakes. We are going to consider the synthetic polymers. So to start with, let us remember why a surface presents itself as opaque or matte. We must consider two types of physical phenomena: the specular reflection that is always associated with a glossy effect, typical of low molecular weight resins like regarates, but also the natural one like mastic, dammer, that thanks to their small molecule, they are able to level the surface and cause an effect of almost perfect reflection of the light. In the case of an irregular or a rough surface, the incident light will be diffused with different angles, and this will cause the matte effect. To give a simple example, imagine the smooth surface of a table. If you abrade it with a sandpaper, it won't show the natural color of the original material. And it doesn't matter if it is made of wood, plastic, metal, or even glass, it will become opaque or matte. This is a typical effect of the high molecular weight resins like the acrylics or the natural like the gamma arabic. Sometimes the matte finishes are not desired. For example, the surface can be irregular due to the degradation of the surface, like a matting of the varnish caused by micro cracking or craquelé, etc., or caused by an excessive cleaning that abraded the surface, and that was not limited only to the dirt layer but affected also the pictorial layer. This is a common scenario in the case of paintings restored with aggressive methods in the past years. So what do we usually do in such cases? In case of the matte surface that we want to bring back to its original legibility, we proceed with the leveling of the surface itself. And this is usually done during the cleaning operation when we use a solvent like white spirit D40 on the surface, where the solvent fills the cavities of the surface itself and thus allow us a temporarily better readability of the color. Alternatively, we can apply a retouching varnish with an effect similar to that of the solvent, because this too will cause a leveling of the surface by filling the cavities and offering a specular or mirror-like reflection. Let's see what happens to the surfaces at the molecular level with the help of an electronic microscope. I'm going to show you some images from the thesis of Miss Ferraris di Selle at the Opificio delle Pietre Dure in Florence. Miss Ferraris, the researcher, has prepared some surfaces using different materials, obtaining different types of glossy finishes. For example, in the top left corner, the initial untreated surface magnified 1000 times with the SEM microscope is quite rough. The surface itself was varnished with different materials on the top right with egg white or albumen to reproduce the ancient manteche, which fractures in its drying mechanism and result in a matte surface. A Sandrak based oil resinous varnish instead, made of a mixture of linseed oil and natural resin such as Andrak, you can see at the bottom left corner is much smoother, and in fact we have a finish that is pretty glossy and brilliant. A similar result we can obtain with a more modern varnish from the 19th century, like the gum mastic in turpentine oil, which you can see in the image at the bottom right corner. All the enlargement at 1000 times shows this difference in their surface response. There are other elements that influence the matte result, not only the quantity of the material applied on the surface or the length of the chain, but also the evaporation rate of the solvent we use for the application. A slow evaporation will allow a better distribution of the material. On the other hand, a solvent with a fast evaporation leaves the molecules in disorder, and which cause the greater ruggedness that we can see. For example, we can see once more from the thesis of Miss Ferraris di Celle two images obtained with a 3D microscope. But on the left, the gum mastic in turpentine oil, that's an extremely slow solvent, and on the right, the gum mastic again, but in a faster solvent like the butyl acetate. We can clearly see that the slow solvent helped in smoothing the surface, while the faster solvent resulted in rougher surface. The line we see here are the marks of the brush used for the application of the varnish itself. Summarizing, fast solvent lead to disorder and greater matting effects, while a slower solvent means increased order and a glossier surface as a result. Let's now take a look at the fixatives that have been traditionally used on the surfaces to obtain a matte effect. Gum arabic, for example, is a material with a high molecular weight, 2050, 300,000 atomic mass units, that has been used also as a binder for watercolors to obtain colors that are not really glossy. To the gum arabic we must also associate other types of gums like the tragacant and the cherry gum, etc. Or the proteic glues, and therefore materials that have been used not only as a fixatives but also as a binders for some types of tempera. The collagen forms a material that can range from 3,000 to 80,000 atomic mass units. We consider the molecular weight of both the gum arabic and the proteic glues to be quite high. Both dissolves in water, the gum arabic in cold water, while the proteic glues in hot water through a more complex swelling mechanism. These materials are soluble in water, and therefore they have a limit as regards the application, which means that they cannot be applied to the pictorial layers that for various reasons must not made wet. After the introduction of the synthetic polymers in the market, there appeared on the palette of the restorers also a vinyl product, the polyvinyl alcohol. The polyvinyl alcohol is a derivative of the polyvinyl acetate that appeared in the 60s. This material has a high molecular weight, and it was initially tested as a fixative for some types of pictorial layers. Also, this material is however soluble in warm water, it is used in concentration from 1 up to 10%, even though this increases the viscosity too much. Therefore, the 10% concentration is advisable more as an adhesive. Still, the introduction of this material has not been able to overcome the problem of the limitation that go with this medium, that is water. Therefore, the search for a fixative that could have been applied with solvent took us to a new category of material, namely the cellulose ethers. Cellulose is a highly hydrophilic polymer, and as represented in this image, it can be modified. That is to say, we can introduce on the hydroxyls that are on the ring of the cellulose ether a lateral group that we can generically represent with a letter R. This R can be simply a methyl, and we will obtain a methyl cellulose, or it can be an ethyl, and so we'll have an ethyl cellulose, or it can be a more complex group, and so we will have materials with complicated names like methyl hydroxy ethyl cellulose or hydroxypropyl cellulose, and so on. Their commercial names are well known, from glutofix to tylose to Klucel, and so on. These commercial names include a range of products with a similar chemical composition, but having different molecular weight. For example, Klucel is available as a Klucel H, Klucel G, Klucel L, Klucel F, and so on. Different letters are associated with a different molecular weight. The majority of this material is still soluble in water, but with some modification we can obtain a partial solubility also in polar solvents. For example, Klucel G is soluble also in ethyl alcohol and in some hydroalcoholic solution, in which we can introduce the isopropyl alcohol. The ethyl cellulose, or what we call ethocell, is soluble in a solvent of a medium polarity. However, this category of material is not soluble in low polarity solvents. Coming to the acrylics, we know they have been used in enormous quantities. And especially when we consider the two most famous names, that is the primal AC33 and paraloid B72. The use of these two materials indeed involves glossy effects, so we need not to do any further investigation on these polymers. Of course, we can add matting agents or particles to these acrylics that will reduce the reflection. It is therefore possible to add materials like micronized silica Lovell or the titanium dioxide, and we will obtain a product that looks more like a paint for certain aspects. A material that has become popular in Italy in the recent years is the so-called acryl matte. This is not a very well-defined product, and there are three types available, all made of acrylic polymers, but these are with different concentrations, and so a quantity of resin that ranges from 1.5% till 3%, and having some not declared matting substances. The solvent might be the hydroalcoholic emulsion or other solution, again, anyway, hydroalcoholic. What is exactly this product? It is difficult to find an exact definition of this material. There is no knowledge of the product. There aren't scientific studies about it or references on previous application, and yet It is a product that, despite the high cost, has become popular. We can try defining this product as a very diluted primal, or in case of Acrymal 2, or a paraloid B82 dissolved in hydroalcoholic solution. This material has a great advantage, seeing the tendency of several superintendents to forbid the use of primal or paraloid on the wall paintings. And so, what is this big advantage? You can actually choose the one you prefer. One can be the use of primal and paraloid without declaring it. And the other advantage is that if you don't know what you are applying, your conscience is okay. The materials we discussed have been studied by Dottoressa Lorenza Pollonia and a group of researchers. They tested with accelerated aging a long list of materials, from the skin glue to the sturgeon glue, Funori, that will be the subject of a next webinar. The Gelvatol, that is the polyvinyl alcohol, Dimension Cluselgi, Aquazol, that will also be part of our next webinar, and then the acrylics like the Plexisol, the Paraloid and Plextol, or the vinylics like Biva 371. Accelerated aging has given a very interesting information. First, the sturgeon glue that was considered as a betterment compared to the skin glues shows a strong yellowing with the photooxidative accelerated aging. Also, Clusel G reveals itself to be not so stable. While the acrylic dispersion Plextol B500 shows very strong yellowing, but this was already known, but this study has further confirmed it. One product that overcomes these problems is Flowline Hy. It is substantially a hydro oil repellent protective that has also reaggregating properties. It is based on fluoroelastomers and has a very high molecular weight. It comes in a solution of acetone and butyl acetate, a pretty fast solvent. And then we have both the characteristics, high molecular weight and fast solvent. Two characteristics that help to obtain a very matte effect on the treated surfaces. The stability is very high. As we can see from a number of studies, here you can see the overlapping spectra of a Fourier transform infrared spectroscopy, FTIR, and GPC, gel permeation chromatography, that will help us to find the variation of the molecular weight with aging. And the glass transition temperature obtained with the DSC, that is differential scanning calorimetry. That is the differential calorimetry. As we can see, all these graphs shows a substantial stability. In the FTIR graphs, there are no spikes due to the oxidation. In the GPC graph, the spectra are almost overlapping. And you can see the glass transition temperatures to remain stable during the time of accelerate aging. Their value remain constant, and considering the accuracy at 1 Celsius degree, we can see stable minus 21 Celsius degrees. I want to show you some application. A polychrome terracotta that was where the consolidation was achieved both on the terracotta layer and on the residue of pictorial layer. The extremely fragile temper of Sironi conserved by the opificio delle pietre dure that compares several products before choosing Flowline Hy because the most stable. Another case is this tempera that was very fragile, and it was the image of one theater curtain at the Castel Fiorentino theater. This theater curtain was to be reused, dismantled, reassembled, and so on. So they needed a material able to be both a matte fixative for the tempera and the pictorial layer, but also a flexible one to be able to sustain the stresses and the tensions caused by dismantling and reassembling operations. Other material could have worked as a fixative with a matte effect, but only Flowline Hy, that is a fluoroelastomer, could adapt to the flexibility of the curtain and resist to its stresses. A new example is on a Seco painting, a very degraded one. In this case, the superintendent asked for a water repellent to protect the paint during the storms, but asked for a reversible one. A classical siloxane protective could have done the protection, but we know siloxane is not reversible. And this is why they opted for Flowline Hy. On this monument, the superintendent asked also for an anti-graffiti, and Flowline Hy is highly reversible because it can be removed with the help of acetone or butyl acetate. So Flowline Hy creates a layer on which the pigment of a spray of the vandal get fixed. And just removing the Flowline Hy, we will remove also the pigment that will not penetrate on the substrate. This is a very particular example of consolidation of a work of art of Rachel Lakovitz, made of a shadow that are practically just compressed pigments without any binder. Once positioned, they started to degrade and powdering, and so the restorers Matteo Cavallini and Davide 32 did their intervention with Flowline Hy, fixing the surface without alteration to the chromaticism and the depth of the opacity. Here you can see the work of art at the end of the conservative intervention. Another intervention where the Flowline Hy was used was on these parchments that during a fire had stuck together and got curled up. On the online references of this work are available with the old name Achiogard CO that now has become Flowline Hy. Also in this study, all this material were tested, and the choice went to the fluoroelastomer because provided the best fixative effect and the smallest visible impact. As last example, a very unusual use of Flowline Hy during the restoration of the Mummy of Agrano conducted by Paolo Malvisi. The consolidation of the skin was required to allow the CAT scan, the computerized axial tomography. And the mummy was to be moved from its case to the hospital, and there was a risk of partially losing the skin. The consolidant was required to consolidate the skin without any chromatic changes. Flowline Hy was applied by brush on the entire surface. The mummy went for the CAT exam, and on the final restoration, Flowline Hy was selected again as a final consolidant because it made the skin also more resistant and elastic. So thanks for watching, and remember to subscribe to our channel and click on the bell button if you want to receive notification on our next video. See you.